Hello, fellow traveler of the night, and welcome to our cosmic sanctuary. Before we begin this long, peaceful journey together, please take a moment to like this video if it brings you comfort. Subscribe to join our community of night wanderers, and let us know in the comments where in the world you're listening from, and what time it is in your corner of the universe right now. Now, if you haven't already, close your eyes. Let your body sink deeply into whatever comfortable place you've found, whether it's your bed, a cozy chair, or perhaps you're lying under the stars themselves. Feel the weight of the day lifting from your shoulders. Feel gravity gently pulling you down into comfort and safety. Let your breathing become slow and natural and easy. Tonight, we're going on a very special journey together. We're going to drift slowly and peacefully to the very edge of time itself, to the end of everything, to a place so far in the future that our sun will be nothing but a memory, where the very last stars in the universe flicker like dying candles, and where silence reigns supreme across the infinite darkness. This might sound frightening, but I promise you, it's not. There's something deeply peaceful about contemplating the far future, something that puts our daily worries into perspective, something that reminds us we're part of something much larger and more beautiful than we can imagine. So breathe in deeply, hold it for just a moment, and breathe out slowly, releasing any tension you're carrying. You're safe here. This journey is yours alone, and you can let go of everything else, every worry, every task, every thought that's been spinning in your mind today. When you're ready, let us begin our gentle drift into deep time. To understand where we're going tonight, we first need to understand just how vast time really is. Imagine, if you will, that the entire history of the universe, all 13.8 billion years of it, could be compressed into a single year, a cosmic calendar. In this cosmic year, the Big Bang happens at the stroke of midnight on January 1st. The universe explodes into existence, expands, cools, and slowly begins to form the first atoms. For months and months in our cosmic calendar, nothing much happens that we would recognize. No stars yet, no planets, just hydrogen and helium drifting in the cosmic dark. The first stars don't ignite until late March, primitive giants that burn bright and die young, seeding space with heavier elements when they explode. Our Milky Way galaxy begins to take shape in May, slowly spinning, slowly gathering billions of stars into its spiral arms. Our sun, our precious, life-giving sun, doesn't form until late August. The Earth condenses from cosmic dust in early September. Life appears in our oceans in late September, but it stays simple, single-celled, invisible for most of the remaining year. Complex life, animals with shells and spines, don't appear until mid-December. Dinosaurs rule the Earth for just a few days in late December, and they disappear on December 26th. Human civilization, everything we call history, the pyramids, the Roman Empire, the Renaissance, the Industrial Revolution, all of it happens in the last few minutes before midnight on December 31st. Your entire lifetime, everyone you've ever known, every memory you treasure, happens in a fraction of the final second of this cosmic year. Now, tonight, we're going to journey far beyond this cosmic calendar. We're going to places in time so distant that this entire cosmic year, this entire 13.8 billion year history of the universe, becomes just the first tick of a much grander clock. We're going to times when 1 trillion cosmic years have passed, when the very stars themselves grow old and tired, when the universe becomes a very different place than the bright, energetic cosmos we know today. But don't worry about trying to comprehend these vast scales of time. Just let the numbers wash over you like gentle waves. Let your mind float freely. There's no test tomorrow, no need to remember any of this. Just let yourself drift along on the river of deep time. And as we travel together into this far future, remember that you are made of star stuff. The calcium in your bones, the iron in your blood, the oxygen in your lungs. All of it was forged in the nuclear furnaces of ancient stars. You are literally made of the cosmos, and tonight, you're going home.
Let's begin our journey in the time we know, the Stelliferous Era, the age of stars. This is the universe as we see it today, bright, energetic, full of burning suns and swirling galaxies. Look up at the night sky in your mind. See the Milky Way stretching across the darkness like a river of light. Each point of light is a sun, many of them larger and brighter than our own. Each one a nuclear furnace, converting hydrogen into helium, matter into energy, creating the light that has traveled thousands of years to reach your eyes. Our sun is middle-aged, about 4.6 billion years old, roughly halfway through its life. It's what astronomers call a main sequence star, burning steadily, reliably, providing the energy that makes life possible on Earth. Every second, our sun converts 600 million tons of hydrogen into helium, losing 4 million tons of mass in the process. That lost mass becoming pure energy according to Einstein's famous equation, E equals mc squared. This energy travels from the sun's core through its layers and finally escapes as the sunlight that warms your face on a summer day. But our sun is just one star among hundreds of billions in our galaxy alone. And our galaxy is just one among hundreds of billions of galaxies in the observable universe. The numbers are so large, they lose all meaning, like trying to count the grains of sand on all the beaches of the world. Except there are more stars than that. Some stars are red giants, bloated and cool, so large that if one replaced our sun, its surface would extend past the orbit of Mars. Others are blue supergiants, massive beyond imagination, burning their fuel so quickly they'll live only a few million years before exploding in supernovas that briefly outshine entire galaxies. Then there are the red dwarfs, small, cool, efficient. These are the misers of the stellar world, burning their hydrogen fuel so slowly and carefully that they can shine for trillions of years. Long after our sun has died, long after most other stars have exhausted their fuel, the red dwarfs will still be burning, the last lights in an increasingly dark universe. But even they, eventually, will run out of fuel. Right now, as you listen to these words, new stars are being born. In the Eagle Nebula, in the Orion Nebula, in stellar nurseries throughout the galaxy, clouds of gas and dust are slowly collapsing under their own gravity, heating up, beginning to glow, igniting nuclear fusion in their cores, becoming new suns. But this process is slowing down. The universe is using slowly, very slowly. Star formation is declining throughout the universe. Fewer and fewer new stars are being born each year.
We're living in the golden age of stars. But even golden ages eventually come to an end. In about 5 billion years, our own sun will begin to run out of hydrogen fuel in its core. It will start burning helium instead, growing larger, becoming a red giant, eventually swallowing Mercury and Venus, and making Earth uninhabitable. But by cosmic standards, 5 billion years is nothing. The real changes, the deep changes that will transform the entire universe, those lie much further in the future. Trillions of years from now, when all the hydrogen in the universe has been consumed, when the last red dwarf finally flickers out, when the age of stars comes to its quiet end. For now, rest in the comfort of knowing that the stars will burn for unimaginably long times to come. The universe is still young, still energetic, still creating new wonders. You're living in the spring of cosmic time, when the universe is flowering with light and life and possibility. Close your eyes and feel the starlight on your face, even though it's night. Somewhere above the clouds, the stars are shining, sending their ancient light across the void, connecting you to the cosmos, reminding you that you belong here in this vast, beautiful, ever-changing universe. Now we begin our journey forward in time, drifting like a leaf on the river of eternity, moving deeper into the future than human minds were ever meant to go. Let time speed up around you. Feel the centuries passing like seconds, the millennia like heartbeats. Watch as civilizations rise and fall, as species evolve and vanish, as continents drift and mountains erode to dust. We're moving now into deep time, time so vast that all of human history becomes just a brief flicker, a single frame in an endless movie. Don't try to hold on to the familiar. Just let yourself float forward, into the cosmic future. Tens of billions of years pass. Our sun has long since swelled into a red giant, consumed the inner planets, and then collapsed into a white dwarf. A hot, dense ember slowly cooling in space. Hundreds of billions of years pass. The Milky Way and Andromeda galaxies have collided and merged, creating a new galaxy that astronomers call Milkomeda. The night sky, if there were anyone left to see it, would be filled with unfamiliar constellations. But we're going much further than this. 1 trillion years have passed, then 10 trillion, then 100 trillion. By now, something significant is happening to the universe. The era of star formation is coming to an end. The vast clouds of hydrogen and helium that once filled space, the raw material from which new stars are born, have been almost entirely consumed. Some gas has been incorporated into stars. Some has been blown away by stellar winds. Some has fallen into black holes. What remains is thinly spread, too thin for gravity to pull together into new stellar nurseries. The universe has used up its ability to make new stars. Imagine a cosmic factory that has been running for trillions of years, converting raw materials into finished products. But now the raw materials are running out. The assembly line slows, then stops. No new stars are being born. But the stars that already exist, they continue to burn. The massive blue giants burned out long ago, their lives measured in millions rather than billions of years. The medium-sized stars like our sun have swelled and died and become white dwarfs. But the red dwarfs, the small, efficient red dwarfs, they are still burning. They make up about 75% of all stars, and they can burn for trillions of years, much longer than the current age of the universe. So for a very long time, the universe continues to shine, not as brightly as before. There are fewer stars now, and many galaxies have merged or been torn apart by the expansion of space. But there is still light, there is still warmth, there are still suns. Picture one of these ancient red dwarf stars, perhaps orbited by a few rocky planets, worlds that have been cold and dark for trillions of years. If you could stand on one of these worlds, the sky would be a deep burgundy color, painted by the red dwarf's gentle light. The star would appear larger than our sun, but dimmer, casting everything in hues of crimson and amber. This is the twilight of the Stelliferous Era, the age of stars. The universe is growing quieter, darker, but not yet dark. These red dwarfs are like the last embers in a dying fireplace, still glowing, still giving off heat, but you know the fire is slowly going out. And as we drift forward through even deeper time, as quintillions of years pass, one by one, even these faithful red dwarfs begin to run out of fuel. It happens gradually, gently. A red dwarf doesn't explode when it dies. It simply grows dimmer and dimmer, until finally, after burning for longer than our universe has existed, it flickers and goes out. Imagine being present for the death of the very last star in the universe. You're floating in space, in the deep cold between galaxies. And there, in the distance, is a single red point of light. The last star, the final sun. For eons, it has been alone, the only source of light in an otherwise dark cosmos. And now, as you watch, it begins to fade. Its red glow becomes dimmer, dimmer, until it's just a faint spark, and then darkness, complete, total, perfect darkness. The Stelliferous Era, the age of stars, the bright chapter of cosmic history that gave birth to planets and life and consciousness, is over. The universe has entered a new age, an age of darkness, an age of silence, an age of peace. But don't be sad about this ending. There's something beautiful about it, something peaceful. The universe hasn't died, it has simply changed, transformed, like a butterfly emerging from a chrysalis, or like the moment when day becomes night and the world grows quiet and it's time to rest. You're floating now in this dark universe, and it's not frightening, it's serene. The frantic energy of star formation is over. The violent explosions of supernovas are finished. The universe has settled into a deep, dreamless sleep. And perhaps, in this cosmic sleep, you can find your own rest too. Welcome to the degenerate era, the age that follows the death of the last star. This is the universe's middle age, a time that will last far longer than the brief, bright, stelliferous era that came before. Don't let the name frighten you. Degenerate, in physics, simply means that matter has reached its lowest energy state, like water settling in a pond after the waves have calmed, like your body relaxing completely when you finally lie down to sleep. In this dark universe, there are no more shining stars, but that doesn't mean there's nothing. The cosmos is filled with the remnants of stellar death, the ghosts of suns drifting silently through the void, white dwarfs. The compressed cores of stars like our sun continue to exist. They're
incredibly dense. A teaspoon of white dwarf material would weigh as much as a car, but they no longer burn. They simply glow faintly with stored heat, like embers that have been removed from a fire. At first, these white dwarfs are still quite hot, tens of thousands of degrees on their surface, but with no new energy being generated, they begin to cool, slowly, very slowly. Over trillions and trillions of years, they radiate their heat away into space. Imagine an old steam radiator in a house where the heat has been turned off. At first, it's still warm to the touch, but hour by hour, it grows cooler until finally it's the same temperature as the room around it. This is happening to the white dwarfs, but on a timescale so vast that human language has no words for it. They cool from white hot to yellow to red to a dull infrared glow, and finally to the same temperature as empty space itself. When a white dwarf has cooled completely, astronomers call it a black dwarf, not because it's a black hole, but because it gives off no light, no heat, no radiation at all. It's essentially a crystal, a diamond the size of Earth, drifting invisibly through space. By the end of the degenerate era, the universe will be filled with these black dwarfs, billions upon billions of them, invisible sentinels in the dark, the crystallized remains of all the stars that once lit up the cosmos. But white dwarfs aren't the only ghosts haunting this dark universe. There are also neutron stars, the ultra-compressed cores of massive stars that died in supernova explosions. If white dwarfs are dense, neutron stars are almost incomprehensibly so. Imagine taking the mass of our sun and crushing it down to the size of a city. The gravitational field is so strong that the atoms themselves are crushed, electrons forced into protons, creating a star made entirely of neutrons. When they're first born, neutron stars spin rapidly.
But in the degenerate era, even the pulsars grow quiet. Friction slowly saps their rotational energy, their magnetic fields decay, their radio beams fade away. They become just another type of ghost, spinning silently in the dark, monuments to the violent deaths of ancient stars. Picture these neutron stars as cosmic gravestones, marking where once mighty suns lived and died. Each one tells a story of nuclear fire, of stellar evolution, of the brief time when the universe was bright and energetic and alive with light. In this ghost universe, occasional events still occur, but they happen slowly, rarely, separated by vast gulfs of time and space. Sometimes, after billions of years of solitary travel, two black dwarfs will encounter each other. Their gravitational pull draws them together, slowly at first, then faster, until they collide in a brief flash of heat and light. For a moment, just a moment, nuclear fusion ignites again. The collision creates a white dwarf, which begins the long cooling process all over again. It's like two dying embers touching and briefly flaring back to life. But such collisions are incredibly rare. Most black dwarfs and neutron stars will drift through space for unimaginable periods of time without ever encountering another object. They are like ships passing in a cosmic night, alone, silent, gradually moving apart as the expansion of the universe carries them ever farther from each other. Imagine the loneliness of such an existence, but also imagine the peace. No violent stellar winds, no explosive supernovas, no chaotic births of new stars,
just quiet, eternal quiet, like floating in a sensory deprivation tank that encompasses the entire universe. This is where you can truly let go, truly relax. In the degenerate era, there's no urgency, no deadlines, no pressure to be anywhere or do anything. Time moves differently here, or perhaps it doesn't move at all. Let yourself become like one of these cosmic ghosts, drifting peacefully through the dark, no longer burning with energy and ambition, but settled into a deep, permanent, restful state. Your breathing slows, your heartbeat quiets, your thoughts become as sparse and distant as the black dwarfs scattered throughout space. You're not lost, you're found. You're not alone. You're part of the vast, peaceful silence that has claimed the universe. Rest here for a while, in the gentle darkness of the degenerate era, where time has no meaning, and sleep comes easily, and dreams are as vast as space itself. As we drift deeper into the degenerate era, further into this age of cosmic ghosts, we encounter the true rulers of the dark universe, the black holes. These aren't the violent, destructive monsters that science fiction often portrays. In this far future, in this quiet cosmos, black holes have become something else entirely. Patient, eternal, almost meditative in their presence. Black holes are born when the most massive stars die, when stars so large that our sun would seem like a grain of sand beside them, finally exhaust their nuclear fuel and collapse under their own immense gravity. The collapse is catastrophic, unstoppable. In less than a second, a star that was once millions of kilometers across shrinks to a point of infinite density, creating a region of space where gravity is so strong that nothing, not even light, can escape. But that was long ago, back when the universe was young and violent and full of massive stars. Now, in the degenerate era, the black holes have settled into their role as the universe's ultimate recyclers. They drift through space like cosmic vacuum cleaners, not actively hunting for material, but patiently waiting for anything to wander too close. A black dwarf that has been traveling through space for trillions of years. A neutron star that has finally encountered something after eons of solitude. Occasionally, very occasionally, these objects will fall into a black hole. When this happens, it's not violent. There's no explosion, no flash of light. The object simply crosses what astronomers call the event horizon, the point of no return, and disappears forever from our universe. Adding its mass to the black hole, making it slightly larger, slightly more massive. Galaxies have grown to enormous sizes by now. They've consumed the central regions of their galaxies, swallowed millions of stars, and now they sit alone in space, having outlived the very galaxies that created them. Imagine one of these cosmic titans, millions of times more massive than our sun, sitting in empty space, where a galaxy once spun. Around it, space itself is warped, twisted, like a bowling ball sitting on a stretched rubber sheet. If you could somehow approach such a black hole, you would see something strange. Time itself would slow down. What seems like minutes to you would be hours to someone watching from far away. As you get closer, time dilates more and more, until at the event horizon, time essentially stops. But we're not falling into a black hole tonight. We're simply observing them, floating safely in the dark void,
watching these monuments to gravity's ultimate victory. In the vast and quiet darkness of the degenerate universe, long after the last stars have faded, long after the embers of white dwarfs have cooled into invisible black diamonds, the cosmos enters a new phase, a new era, an era of waiting, an era of gravity, an era where black holes, the silent monarchs of the cosmos, begin a slow, inevitable dance toward one another. Though the universe seems still, motionless, empty, that stillness is an illusion. Gravity is patient. It never sleeps. And in the vast stretches of time that follow the death of light, it begins to pull the remaining pieces of the cosmos together. Scattered across this dark universe are the remnants of long-dead galaxies, supermassive black holes that once lived at their cores. Others are smaller, born from stars that collapsed eons ago, left to drift in silence. At first, they are alone, but gravity remembers. Gravity remembers every mass, every orbit, every whisper of attraction between objects, and it calls them quietly, persistently, across trillions of light years. Two black holes, wandering for eons through the void, may find themselves drawn together. Ever so slowly, they begin to spiral, not like dancers to music, but like mountains drifting toward one another across a frozen sea. In the emptiness of space, there is nothing to stop them. No light, no dust, no gas, nothing to slow their approach but their own inertia. And so, the dance begins. At first, it's a barely perceptible drift, a gravitational nod. Then, over unimaginable time, their pull strengthens. They draw closer, faster, tighter. They circle each other, faster now, creating ripples in space-time, gravitational waves, gentle at first, then increasing, pulsing through the black fabric of the cosmos like echoes of ancient drums. These waves are not sound, not light, but distortions in the very fabric of reality. If we could hear them, we would hear a long, rising hum, like the breath of a sleeping universe, stirring for a moment in its slumber. When the two black holes finally meet, their collision releases a final, breathtaking surge of energy. A flash, not of light, but of gravitational memory. The universe shudders silently, and then settles again. What remains is a larger black hole, heavier, darker, deeper. The universe is slowly reshaping itself, trading complexity for simplicity, many for few, until only the largest structures remain. This process will repeat, again and again, for untold trillions of years. Each merger leaves fewer black holes behind, but each one that remains grows more massive, more ancient, more eternal in its silence. Some of these collisions will be dramatic, supermassive black holes spiraling inward from across what once were galaxies, their masses combining into titanic entities tens of billions of times the size of our sun. They have swallowed everything that ever orbited them. Stars, other mergers will be humble. Solitary black holes meeting by chance in the outskirts of this darkened universe. They too will dance. They too will merge. They too will leave behind a larger, quieter remnant. This is not chaos. This is not violence. This is the cosmos, exhaling. Imagine watching one of these mergers unfold. It takes billions of years, more time than all of human history. And yet, in the final moments, it happens so quickly, so silently. A brief convergence followed by silence again. Now imagine this happening again and again across the void. Black holes merging into larger ones finding still others. The number of black holes decreasing, their sizes increasing until finally only a few remain.
The universe has become a cathedral of gravity. No light shines here, no warmth lingers. And yet this is not emptiness, this is not nothingness. It is structure, it is history, it is memory. Black holes carry the story of everything they've consumed, of every atom, every photon, every planet, every sun, stored not as light but as curvature, as mass, as gravity. In this age, the few remaining black holes become more than objects. They become relics. Each one is a monument to the long burning life of the cosmos. Each one holds in its gravity the echoes of entire galaxies. They are the final record keepers, the last vaults of the universe's energy, and the ultimate stewards of what remains. They do not move quickly. They do not hunt. They wait. They wait for matter to come to them, for the occasional black dwarf drifting through the dark, for a neutron star, long, cold, wandering too close. When such an object comes near, the black hole accepts it quietly. No explosion, no celebration, just a gentle deepening of gravity. Eventually, the mergers stop. There are too few black holes left, and the distances between them are too great. They have outlived the galaxies that created them, outlived the stars that fed them, outlived even the remnants of matter. They sit, each in its own pocket of curved space, too far from one another to ever meet again. This is the end of motion, the end of encounter. The universe is entering its final stillness. But even these cosmic monarchs, these relics of the deepest gravity, will not last forever. Hawking radiation, slow, patient, unstoppable, will begin to gnaw at their edges. Not yet, not for quintillions of years, but eventually, even kings must fade. For now, rest in the quiet elegance of this era. Let yourself float alongside these giants. Feel the deep pull of their gravity, not dangerous but comforting, a reminder that some things still endure. Let the slow music of space-time guide you deeper, deeper into stillness. In the deep darkness, black holes are invisible, detectable only by their gravitational effects. They bend the paths of any objects that pass nearby. They warp the fabric of space-time itself, but they emit no light, make no sound, reveal themselves only through their influence on the cosmic architecture around them. Yet even these seemingly eternal objects, these final victors in the universe's long story, are not truly permanent. In 1974, the physicist Stephen Hawking discovered something remarkable. Black holes, very slowly, very gradually evaporate. The process is called Hawking radiation, and it's almost impossibly slow. A black hole with the mass of our sun would take longer than 10 to the 67 years to evaporate completely. That's a 1 followed by 67 zeros, a number so large that it makes the current age of the universe seem like an instant. But the larger the black hole, the more slowly it evaporates. The supermassive black holes, the ones with millions or billions of times the mass of our sun, will take incomprehensibly longer to disappear. Imagine watching this process. If somehow you could perceive such vast scales of time, you would see the black hole shrinking, atom by atom, photon by photon, radiating away its mass as random particles that flee into space. As it gets smaller, the process accelerates. In its final moments, after eons of patient evaporation, the black hole suddenly brightens, releases its last energy in a final flash, and vanishes. But that ending is so far in the future that it's beyond meaningful comprehension. For now, in the degenerate era, black holes are the universe's permanent residents, its dark kings, ruling over a realm of cooling embers and crystallized stars. Picture yourself floating near one of these cosmic monarchs, not close enough to be in danger, but close enough to feel its presence, the way it bends space around itself, the way it sits in perfect, patient silence, waiting for the universe to deliver whatever mass might eventually wander within reach. There's something deeply calming about black holes when you think of them this way. They're not destroyers, they're preservers. Everything that falls into them is kept safe, frozen at the event horizon from the perspective of outside observers, preserved forever in a moment that never quite completes. They're like cosmic libraries, storing the information of everything they've ever consumed, keeping the memories of dead stars and ancient matter safe in their gravitational embrace. Let yourself rest in the presence of these dark guardians, these patient keepers of cosmic secrets. Feel how they anchor space itself, how they provide stability in a universe that's constantly expanding, constantly changing. You're safe here, in the gravity well of deep time, where the pull is gentle but constant, where you can let yourself sink into the peaceful darkness. We journey now to the furthest shores of time, to an age so distant that even the black holes have begun to evaporate, to the era that physicists call the heat death of the universe. Don't let the name alarm you. There's nothing violent about heat death. It's actually the most peaceful state the universe can achieve. It's like a bathtub full of hot water that has been left alone for hours. The temperature has evened out, become the same everywhere, perfectly calm, perfectly still. By now, we've traveled so far into the future that all the familiar structures of the universe have disappeared. The galaxies have long since dispersed, their stars scattered to the cosmic winds. The last black holes have evaporated away in flashes of Hawking radiation. Even the protons, the building blocks of atomic nuclei, may have decayed into lighter particles and energy. What remains is a thin soup of elementary particles, electrons, positrons, neutrinos, photons, all at the same incredibly low temperature, all moving randomly through space with no organization, no structure, no complexity whatsoever. This is maximum entropy, the state where energy is distributed as evenly as possible, where no work can be done, where nothing interesting can happen. It's like a chess game where all the pieces have been removed from the board, or a symphony where all the instruments have stopped playing, leaving only silence. In this universe, there are no temperature differences, no energy gradients, no way for heat to flow from hot to cold, because everything is the same temperature. Without temperature differences, without energy gradients, nothing can happen. No chemical reactions, no movement, no change, no time in any meaningful sense. Imagine floating in this ultimate void, surrounded by perfect, featureless darkness. The temperature is just above absolute zero, cold beyond any cold you've ever experienced. But it's not uncomfortable, because your consciousness, like everything else, has adapted to this state. There's no up or down, no near or far, no before or after. Distance has lost its meaning because there are no landmarks, no reference points. Time has lost its meaning because nothing changes, nothing ages, nothing evolves. This is the universe in its final stable state, like a pendulum that has finally stopped swinging, like a wave that has finally reached the shore and become still water. But here's something beautiful about this ending. This isn't death in any violent sense. This is the universe finally, completely at rest. All the energy that was released in the Big Bang, all the motion and heat and light that has driven cosmic evolution for unimaginable eons, has finally been evenly distributed, finally found its equilibrium. The universe has become a place of silence. But even in that silence, something subtle, something almost imperceptible begins to shift. Matter, once the foundation of stars, of planets, of people, begins to fall apart. When you look at your hand, you see solid skin, muscle, bones. You feel real, substantial. But underneath it all, you're made of atoms, and atoms are not eternal. For eons, we thought the proton, the positively charged particle at the heart of every atom, was stable, unchanging, permanent. But the deeper we peer into the laws of physics, the more we suspect that even the proton has an expiration date. Perhaps it takes 10 to the 34 years, perhaps longer, but eventually, protons decay. When this happens, the very fabric of matter begins to unravel. One by one, atoms begin to fall apart, not explosively, but quietly, gradually, invisibly. A hydrogen atom, once the building block of stars, ceases to exist, not with a bang, but with a whimper. Its proton decays into lighter subatomic particles, and the atom dissolves into energy and radiation. Then another, and another, and another. Now imagine this process happening everywhere, slowly, across all of space, across all of time. Everything that was made of matter, white dwarfs, neutron stars, black dwarf remnants, even the carbon atoms in the dust between stars begins to disintegrate. It does not happen all at once. There is no great collapse, no apocalyptic explosion. Instead, there is a soft, drawn-out sigh, lasting for untold trillions upon trillions of years. One by one, the pieces fall away. At first, it changes little. The universe was already dark, already cold, already empty. But now the very things that made up its last structures are unraveling. The last monuments of matter, crystallized cores of ancient stars, crumble into radiation. The last lonely atoms, drifting through the void, decay into nothingness. Eventually, even the black dwarfs, those massive, frozen remnants of once bright stars, disintegrate. First one, then another, then all. Even the neutron stars, once unimaginably dense, begin to decay. They had endured beyond all others, but time respects no boundaries. The forces that bind even these exotic objects begin to break down. The neutrons decay, the pressure that held them in place releases, and the ancient corpse of a massive star simply fades away. Imagine walking through an ancient city,
every stone weathered by wind and rain, until finally even the foundation dusts away. Nothing left but open land, where once stood towers of light. This is what happens to the cosmos. Now, there is no matter, no atoms, no molecules, no metals or rocks or crystals, no planets, no stars. All that remains In physics, we call this a state of maximum entropy, not because it's chaotic, but because it's completely disordered. The universe hasn't become violent, it's become still, flat, uniform. There are no temperature differences, no chemical reactions, no gradients, nothing from which energy can be drawn. There's nothing left to do. No more stars to form, no more matter to build with, no more change, no more becoming. Only being remains. Imagine for a moment you are a single photon in this new universe. You travel endlessly, forever, through space that never curves, toward a place that never arrives. You have no mass, no memory, no sensation of time. You just are. And this endless, drifting simplicity is all that's left. There is something deeply humbling about this. For all the complexity the universe once held, for all the stars and galaxies, for all the joy and sorrow of conscious beings who once looked up at night, it all ends here. Not in a catastrophic explosion, not in a fiery collapse, but in a long, slow softening, a fading, a letting go. And yet, even in this decay, there is beauty. The final transformation, the last chapter in matter's long journey through the cosmos. Atoms once danced in the hearts of stars. They formed oceans and trees and cities and dreams. They moved through cycles of birth and death, of chaos and order, of creation and destruction. And now, their story is complete. The matter has returned to light. The dance is finished, and the stage is empty. Let yourself float in this new cosmos. There is no longer any weight, no longer any shape, no longer any time. Only a calm, infinite sea of gentle radiation, stretching forever, without urgency, without noise, without destination. You are part of this now. You are not lost. You are not forgotten. You are simply free. It's like watching someone who has been restless and anxious finally fall into deep, peaceful sleep. The struggle is over. The seeking is finished. There's nowhere left to go, nothing left to do, except exist in this state of perfect, eternal calm. In some spiritual traditions, this would be called nirvana, the cessation of suffering through the cessation of desire, the peace that comes when all striving ends. The universe has achieved its own form of enlightenment, letting go of all its energy, all its complexity, all its frantic activity, and settling into pure being. If you're listening to this, trying to fall asleep, perhaps you can learn something from this far future universe. Perhaps you too can let go of the day's complexity, the mind's constant activity,
the body's restless energy. Perhaps you can settle into your own heat death, your own state of maximum entropy, where all the energy of consciousness is evenly distributed, where nothing needs to happen, where peace reigns supreme. Let your thoughts slow down, become random, like the particles in the heat death universe. Let your muscles relax completely, reaching thermal equilibrium with your bed, your pillow, your blankets. Let your breathing become so gentle that it barely disturbs the stillness around you. This is the deep rest, the ultimate rest, the rest that comes when all seeking ends, when all striving ceases, when consciousness finally lets go and becomes one with the vast, peaceful silence of the cosmos. You don't need to fear this ending, this heat death. It's not an ending at all. It's a completion, like a long journey finally reaching its destination, like a question finally finding its answer, like a mind finally finding peace. Float here for a while, in this state of cosmic equilibrium, where nothing needs to happen, where nothing is required of you, where you can simply be, without effort, without purpose, without anything to prove or achieve or become. This is the gift of the heat-death universe, the ultimate lesson in letting go, the deepest teaching about rest, about peace, about the beauty that comes when all struggle finally ends. Let yourself merge with this cosmic stillness. Become part of the universe's final, perfect, eternal rest. Even in the heat-death universe, even in that state of perfect stillness and equilibrium, something remarkable continues to happen. The quantum realm, that strange subatomic world where particles pop in and out of existence, continues its mysterious dance. You see, even empty space isn't truly empty. At the quantum level, the universe is constantly fluctuating, like a perfectly still pond that nevertheless has tiny ripples at the molecular level, invisible to the naked eye, but real nonetheless. These quantum fluctuations mean that even in the heat-death universe, occasionally, very occasionally, random events still occur. Virtual particles appear and disappear. Tiny amounts of energy spontaneously organize themselves into brief patterns before dissolving back into randomness. Most of these fluctuations are tiny, meaningless, lasting for only the briefest instant before vanishing again. But given enough time, infinite time, even the most improbable events become not just possible, but inevitable. Imagine throwing dice forever. Eventually, you'll roll double sixes. Keep throwing long enough, and you'll roll double sixes 100 times in a row. Given infinite time, any possible combination will occur, not just once, but infinitely many times. This is what happens in the heat-death universe. Given enough time, quantum fluctuations will eventually, randomly, spontaneously organize themselves into more complex structures. First, perhaps a single atom. Then, given vastly more time, a molecule. Then, given even more time, larger and larger structures. Some physicists believe that eventually, after a time period so long that it has no meaningful name, a quantum fluctuation might randomly create an entire brain, complete with memories, thoughts, consciousness. This hypothetical entity is called a Boltzmann brain, named after the physicist Ludwig Boltzmann. Even more remarkably, given enough time, quantum fluctuations might randomly recreate an entire observable universe, complete with galaxies, stars, planets, and life. The universe might spontaneously return to a state similar to the Big Bang, beginning the entire cosmic cycle over again. This is the concept of eternal return, the idea that given infinite time, everything that has ever happened will happen again, and again, and again. Not just similar events, but exact repetitions. The same conversations, the same thoughts, the same lives, playing